The first video about direct and inverse variation had to do with setting those direct variation problems up as a proportion or inverse variation problems up as a product. There is another way of thinking about that, and we're going to talk about this method for direct variation problems that builds an equation. So the major drawback to thinking about direct variation simply as a proportion is it's difficult to generalize the solution, to see the mathematical pattern. We can set up proportions when we're dealing with just case A, case B, and solve it. So it's harder to do more complex problems. Specifically, it's harder to do joint variation problems, which is one of the things that we're going to get into. So what I mean by this is what we talked about in the first video is that direct variation followed this proportion. But another way to think about that is to say that this proportion just equals a constant of variation, k. We can manipulate this equation to by multiplying x on both sides to end up with y equals kx. This is a model for direct variation. Let's use this model. Find y when x equals 5 if y varies directly as x and y equals 36 when x equals 2. So we have situation unknown. We don't know what y is when x equals 5. We see the type of variation, and then we have a situation that we know both parts. We could set this up as a proportion, but instead, let's solve this using the y equals k times x equation. So the first thing is that these are x and y values, but they don't directly tell us the k. What we're going to have to do is we're going to have to plug in the information that we do know in order to find the constant of proportionality. So that means since y equals 36 when x equals 2, this becomes 36 equals k times 2. Notice what I had to do first was I had to figure out what form of the equation this was going to take. What told me the form was this bit that says y varies directly as x, or just thinking through that this is the type of variation. You may have heard my dogs barking a little. So the first thing we want to do is find the form of the equation, then plug in what we know to find the constant of variation, the constant of proportionality. To do that, I'm going to divide both sides by 2. We end up with 18 equals k. So there's our constant. What this tells us is that all of the problems in this mathematical relationship described here follow the equation y equals 18x. And so that means we can actually find y when x equals whatever. We could plug in -1 for x. We could plug in 27 for x. In this case, we want to figure out what y is when x equals 5. So this right here is our equation of variation. And with it, we can solve any situation. We could solve y for any x value asked. So in this case, we have y equals 18 times 5. 18 times 5 is 90. So there's our answer. Thank you.